Fire in the West is a growing problem. With decades upon decades of drought, we are seeing major fire after major fire. Over the recent years, I think the entire nation has started to appreciate this and the importance of understanding fire, because smoke transports across the country. It affects us here in Colorado quite a bit, but on the East Coast we've seen plenty of major smoke events now as well. CIRA has been heavily involved with developing new tools for characterization of fire. So monitoring of fire from space, for example. We have satellites up there right now that do a great job of detecting the fire, either at high spatial resolution and in other cases in high temporal resolution, so you can watch the fire evolve. And of course we have imagery tools that allow us to see the smoke being produced by these fires, and then that smoke being transported downwind, which affects air quality and our respiratory health. One important aspect of that work is early detection of fires, where hopefully with the right near real-time tools you can spot a fire in its early stages and maybe go do something about it before it turns into one of these incredibly out of control and wild blazes. That's something that we refer to right now as the Next Generation Fire System. It's a collaboration with NOAA and other partner institutes to take satellite information and get it into a near real-time kind of alert framework, where a fire happens and boom, there's an announcement of here's where it is and here's its properties right now. Go do something, right? Yeah. So that's kind of the detection and early warning aspect of our activity. Another one is the fire weather testbed, where it's kind of a repository of resources that is being managed by NOAA, both in terms of detection of fires, but also modeling and what is a fire going to do next, given that it's here, here's the fuel types, here's the weather, here's the winds and the moisture and the environment, and taking those things all together and then trying to predict where that fire is going to go over the next several hours. So imagine, a fire team or a hotshot crew out there on a wildfire, and they have a fire boss that's telling them where to go to most effectively fight the fire, and you might have an incident meteorologist on site as well, who's the weather liaison for what's going to happen. These folks all need accurate and timely information on what that fire is doing and what we think it's going to do next. So we're plugged in with that aspect as well, which is a very kind of new and exciting way of approaching fire, where we're consolidating all the resources together for a common good. One of the interesting stories that I like to tell about how CIRA takes problems and challenges and tries to address them into practical solutions has to do with a tragedy that happened in 2013 in Prescott, Arizona, where the Yarnell Hill fire was burning out of control, the wildfire. The Granite Mountain Hotshots were a crew that were fighting this fire, and they were on, I believe, the southwestern line of that fire, attacking the line on its blaze. And out of nowhere, kind of, convections or thunderstorms built up in the east. And in that part of the country, the lower atmosphere is often very dry in the desert southwest. And so when rain falls into a dry atmosphere, it will evaporate, and that evaporation cools the air, and it creates what's called negatively buoyant air. It sinks really quickly when it's colder than its environment because of the evaporation of the rain, and it hits the surface and it fans out almost like a pancake on a griddle or something, and that air goes out in all directions. It's called a cold pool or an outflow from the thunderstorm. Well, in this case, where the Granite Mountain Hotshot crew were fighting the fire, this outflow came in from the east-northeast, and it basically changed the entire direction and intensity of the fire as these strong winds blew over from a completely different direction than what was blowing before. It caught the entire crew off guard, and they scrambled to get out of the way, but they could not. They had to put their fire blankets down, and the fire raged over them, and very unfortunately it killed all 17 of the crew. So with that as a backdrop, we asked, how could we possibly avoid this? What went wrong? How could we avoid this in the future? And there's a realization that, the models can do pretty good with convection, these thunderstorms that cause these outflows, but not always in the exact locations where and when and timing of where they're actually happening in nature. And in this area, there's a sparse radar coverage and terrain blockages that make the surface radars less useful. So what we ended up doing was developing a satellite-based estimate of radar. And this is where machine learning came into play, where we took satellite information and lightning information and trained it against actual radar data to come up with a synthetic radar product. The name of that product is GREMLIN. I'm not going to try to spell that out, but it has to do with using GOES and lightning. That's the G and L are in there. But with GREMLIN, we are actually able to render a synthetic radar picture. And we found that taking that radar information and putting it into a model initialization, this is where you start the model off on an initial state so that it can run forward and see what's going to happen next. Using Gremlin and initializing that model, we could actually do better with predicting where convection was happening than the actual radar data itself. So we're taking advantage in that case of satellite information that's providing coverage in these areas where the radars are not providing as good coverage. These kinds of tools are really important because nature and history sometimes repeats itself in different ways. And many years later, there was a fire in Midland, Texas, southwest Texas, a grass fire, and firefighters were once again fighting on the southern flank of that blaze. Once again, strong thunderstorms were forming on the northern area of the region, creating these outflow boundaries, once again, the cold pools that were racing down towards that fire, and it almost looked like history repeating itself. And but in this case, the Midland, Texas Weather Forecast Office, the National Weather Service, were able to use satellite imagery in this case to actually say, hey, look, we see an outflow coming, and get your crew and the equipment off of that southern flank of that fire before that outflow arrives. And they were actually able to, in real time, receive that information, move off the southern flank and outside of harm's way. So this is, a kind of a vignette of the way that we function, and what's important for us is learning from the past, applying science and research toward new tools that can help avoid repeating history in the future.